system. So we'll try to finish two chapters today actually. We'll try to finish 1.6 and 1.7 because I know there's a little bit of programming. There is not little bit of programming, but I decided that because I have my own book for Python, but I'm going to use this lecture and then learn Python from it. So I'm going to do Python today and then MATLAB tomorrow and then C, embedded C on the next day, and then it's going to go reverse again and again. I'll try my best. I do one course, but um, I may do two courses today, MATLAB and because I don't have work just for today, but every Friday I'll try my so which means every Thursday because I also work overnight. Every Thursday, what I'll do is I'm gonna do like two lectures rather than one. So I think that's better. Did I copy this already? This is the continuation. Nope, this is not the continuation. This is a different one. So there are five. There'll be five pasted texts. Sorry if I don't, you know, look good or whatever. Cause I mean, I need to switch off the light, and we'll switch on my lamp light in a second. Just give me 2 seconds. Give me 2 seconds. Copy everything. So once chapter one is done, what I'm going to do is do a full lecture on the entirety of chapter one. I'll try my best to explain it as easy as possible. So I think that's it. Okay, there are five pasted texts. Can you just check how many sections are there for each pasted text? All right. Hi, people. Hello. Hello. Anyways, I need to. Um, need to quickly mention it quickly. X of k will be 10 equal to x of k will be 10 equal to x of k will be 10. Wait, let me just quickly. Let me quickly. But dude, I want people. Whoa. I want people to see like, yeah, you're streaming. Let's fucking go. I want that shit. I want that shit. Ooh. There. Circle. I'm just gonna do it quickly. I swear I'm gonna do it quickly. Oh, the coffee is so good, man. It is raining. It's fucking raining. It's good. The coffee is good. Oh. Oh, so good. The coffee is really good. The coffee is really, really good. This is me learning aerospace engineering. Who's that? All right. Wait. Just 2 seconds, 2 seconds, 2 seconds. I just need to post it everywhere. Oh God. What I'll do, I'll delete that and delete that. I post a new story. You shouldn't have any, yeah. That, and then go to C++, to that, and then go to, yeah, MATLAB. I did that. C++, Rust. I did it. Julia. Engineering theory and myself too. Anything else I'm missing? Um, MATLAB, myself, engineering theory, Julia, Rust, C++. CUDA is not there. Arabic. Mm, what else is there? French is there. And then I'm gonna post it everywhere, everywhere. That was my entire plan. Post it everywhere because I want people to watch. Because I want them to see, like, what I do and stuff like that. Kick.com. Yes, I know I should have done this earlier. I know I should have done this earlier. I'm so sorry, but I don't have work. Today is a nice weather, so I don't want to think anything negative today. Today coffee is also good. The coffee is really good because usually I put like a lot of coffee. I literally pour the entire thing. So there's the bad part. Yeah. Nope. Nope. Kick.com/Sagar Ahmed FIP. We're gonna do 2 chapters here. Don't worry. Um, I wish I was like one of those guys where if once I post out, because then everyone's going to watch and stuff like that. I wish I was that kind of person. Are we good? It's the World Cup. Right? Let's go. Get it. Let's get it. Let's go. All right, let's do so 65. Oh shit. All right, it'll be 1.6.1. Hmm. Can we do like can we for each pasted text, can we combine like from 13 sections to like 13 sections, combine two sections, like three sections into one. So we will have around four sections then for each. So 24 sections for no 20 sections. So 20 sections. 20 sections for all five, basically. First of all, what are the 13 sections? Like name for them so that I can combine them for. Today is a good weather. Today is really good weather. And I'm not doing any timer or whatever. Didn't I do this already? Like, it's so weird. Like, why does it feel so similar? Like, controlling aircraft, trim point, lift equals weight condition, static stability. What is control? Why does it feel like I've done this again and again and again and again and again? Wrong. Wrong. I meant, yes. Yes. Let's do that. Yes. Your method is correct. So let's do the latex code for it. And for the for each section, label it section 1.6.1, 1.6.2, 1.6.3, and 1.6.1, 1.6.2, 1.6.3, 1.6.4, and 1.6.5. Stop, stop. France, I'm gonna buy the France. How much is the France 2026, 2027 kit? Ooh, $140. That's good. That's a good price. Oh, Qatar. I'm gonna. How much is the Qatar? How much is the Qatar jersey? Oh, that's nice. Qatar. I don't want the away kit. I want the home kit. The home kit isn't out yet? Nah. Oh yeah, the home kit is out. Qatar 2026, 2027 kit. That looks nice. Qatar will play against Canada. That's purchase. Let's see how much are they. Enjoy F ball. You should check out their website. Enjoy F ball. They're really good. Really, really good. Like it's really good. Qatar. How much is a Colombia kit? National team Colombia. Yeah, I'll buy the Japan. Japan's one is really good. I like that. I like that kit. Itachi. I'm gonna buy this. I'm gonna buy this kit, this Itachi kit, and I'm gonna buy the Qatar kit. I'm gonna buy the Itachi's kit, and I'm going to where's the Argentina? And I'm gonna buy the Qatar home kit. Yeah, I'm excited. I'm excited. Yeah, yeah, yeah. We can do that. We'll do that. We'll do that. Yeah, we'll do that. That's great. Let's begin. Let's begin. Begin. We don't have time to waste. Have time to waste. I'm excited. I'm excited. I'm excited. I'm really excited. Really excited. I'm really, really, really excited, man. I'm glad, man. I'm glad. Let's go. Let's go. Let's go. Let's go. Okay, what the fuck is this, dude? Come on, man. No, I meant Oh, fuck! You're ruining everything, man. You're ruining everything. Okay, okay, we get it. We get it. Just do it, man. Explain. God, explain. Like, come on. Begin explanation. Begin your explanation. Like, come on, man. Like, start. Do the latex code with explanation. Explanation. Because I don't know anything about this. I mean, I need to study, right? Like, it's not like, oh my god, I know everything. What the fuck is this? It definitely looks very weird. It looks very weird. I don't think it'll work. I don't think this will work. The only reason it's not going to work is because one, you're missing the document there and whatever. So it's going to be like begin document and then you need to edit. So you need to do your style edit. You need to do your margin edit. So you miss that. Second of all, you have like so many percentage is fine, but it looks letter is it letter size or is it A4 size? I don't know, but it looks very weird. I can pretty much say it's not going to work. I have very high hopes, like low hopes that it's going to work. Not high hopes, low hopes that it's not going to work. I can guarantee you, you're missing the. Okay, you're also missing the begin doc. You're also missing that begin document whatever. Today is good weather. Today is really good weather. Yeah, I'm just gonna copy that shit there. Oh, you can't fuck's sake. Today was a good day. I got the offer letter for being a teaching assistant, which means I will be both TA and an RA. So like I'm gonna be TA for once per week, and obviously RAs there too, right? But yeah, I'm excited. I'm very excited. It's June. First of the month. Feel good. I feel really good. Look, I told you, you ruined it. I knew it because this is what you do. Go to DeepSeek because if you keep, the more you um say the can you fix it, can you fix it, can you fix it, it won't be able to fix it. So what you do is go here, go to DeepSeek. DeepSeek can fix it. I don't know what the fuck is going on. What the fuck is going on? But can you fix it? And I need to change my title to uh, view channel. Is it view channel? No, create a dashboard. I need to change my. This is Python programming. No, this is not MATLAB. This is Python. Python programming. Python programming and finishing up and finishing chapter 1.6 and 1.7. Because once I have the book, yes, I know I'm using AI, but for editing and stuff like that. But then, I mean, obviously, everyone uses AI to, study and stuff like that. That's it? Wait, that's it? No, that can't be, man. Wait, why is the explanation so less? Wait, that's it? Why isn't the explanation detailed? You missed a lot of stuff. Okay, you know what? So this and okay, is it possible to fix it? I see that it is not even detailed enough for students to understand what is going on. So can you fix it, please? See, I told you. This dumbass man. I swear I'm not gonna pay for this AI shit. This chat GPT shit. I'm not gonna pay for it. You have like DeepSeek, man. You have DeepSeek. I learned embedded C from DeepSeek. It's free, for fuck's sake. It's fucking free, man. I don't know why do people not use DeepSeek. I mean, Anthropic is there, but DeepSeek, man. For me, like DeepSeek is goat. Like I'm gonna keep using DeepSeek. I don't know, and DeepSeek is like free. Like, do you pay for it? I mean, even if there was payment option, I would do it. Grok is good. Okay, that's a lot. Okay, um, so there's supposed to be. Let me just. I'm so sorry. I'm so sorry. I'm so sorry, dude. Man, this ChatGPT ruined it, man. You ruined it. You fucking ruined it, man. Fucking dumbass bitch. They ruined it. They ruined it, man. Dude, you missed so many stuff, man. So many stuff. Just gonna go up. So these, thank God he has. So these are the chapters. Is it possible? So these are the chapters. Can you do it again? Like this time with the modifications. Yeah, you can see like how I edit and stuff like that because I don't know how to do latex code. I don't know. I don't know how to do latex code. I'm not here to learn about latex code. I'm here to learn about engineering. And I don't have a professor or anyone who can teach me engineering. And obviously, they have this. You see that show transcript? They have that. Boom. Come on, come on, come on, come on, man. Oh, yeah, it's taking time. Okay. Man. I'll take it. I know what's going on. I'm going to do 1.6.1 first. So this is the entirety of 1.6.2. Oh, I can copy it. How am I sitting down? I'm just going to copy all those. I'm going to finish 1.6.1 first, and then I'm going to copy 1.6.2. So core explanation. Trim means all forces and moments sum to zero. So the missile flies straight without rotating. So it's a hypersonic missile. The hypersonic missile. So I have to mention that. The hypersonic missile flies straight without rotating. So it doesn't rotate. So unlike a rocket, which sometimes may rotate, a missile doesn't rotate. The force equilibrium, the force on the x-axis is zero. So you have, so on the x-axis, what do you have on the x-axis? So it's like a rocket, right? You have the tail that's aimed, because unlike a rocket, which is like slanted, so that'll be for y-axis, right? But the missile is like, fuck's sake, it's kind of like horizontal, right? And so you're gonna say that your drag force is not, because if you look at a rocket, the drag will be downwards. So in a rocket, you're not only going to add drag, but you're also going to add weight. So drag plus weight in your rocket, and the thrust will be the y-axis going up. The y-axis going up will be the thrust and external forces that pushes the rocket upwards. And in terms of the downward force, there'll be the drag force and the weight force, right? But in a missile, you have what? You have the drag force that's coming from, like, in front of me, from the horizontal point of view. So that's your drag force. And thrust force is not from here, like, but it's from here. Like, yeah, so there'll be engine. So that's the drag force. And for it to be equilibrium, the amount of thrust applied to make sure that the missile flies, equal amount of drag force will act opposite, obviously, equal and opposite force. That's the, is it the first law or is it the second law? Oh shit, I think it's the first law, whatever. And then F for z axis, there is no y axis, because if you look at a 3D point of view, people will presume that this is y axis and this is x axis. But y-axis is, if you do x, y, and z, this will be your z-axis, this will be your x-axis, that will be your y-axis. If you like draw a graph, let me just show paint, just for 2 seconds, let me just show you paint. So in a 2D graph, it'll be x and y, right? But in a 3D, if you were to tilt it, so let's say for example, that's my graph over there, and I'm seeing it from here, then instead of x and y, it'll be, that will be, so it's kind of a flatten out, so it's kind of like flatten out, right? You have a y here, you have a x here, you have a z here, right? So if you look at from the diagonal, you're gonna see that it's more of like, the y is more of like flatten out. So what you see, this x and y, it's like you're looking from top, but in reality it's not like, so in reality it's like x and y, but y is, this isn't y, that's y, and that's z. And then f of z, that's the lift and the weight. Lift, wait, I'm not making sense, right? Lift and weight, lift and weight, why would that be f of z? Okay, wait, I'm not making sense, shit. I have one question. I'm stupid. I am stupid. Why is that z? Shouldn't that be y? I'm confused. Why would that be lift and weight? Lift and weight. Lift. Lift. Why would rocket have a lift? Lift and weight? Weight, yes, because as it flies, there will be weight. That's a y-axis, you motherfucker. That's a y-axis. That's not a z-axis. Wait, why is it f of z? Shouldn't it be f of y? Yeah, that should be f of y. Wait, I'm stupid. X is the forward, that's the nose. Y is the right wing, and Z is the down. So F of Z is the vertical force. F of Y, oh, oh yeah, yeah. Okay, wait, how? So I know what a side slip angle is. Obviously, it's gonna move left or right. That I know. But that's why? Wait, side slip angle is Y? I know X is the forward, Y is the up, Z is the right. That's the general physics. That's the general one. No, he's right. No, no, no. What I'm saying is right, but I'm using the general one. This is not the general one. It uses aircraft convention, standard in stability and controls. Yes, yes. The L horizontal is L sine of phi. Yes. Oh, oh yes. Okay, yeah. That going up or going down, that's the cosine. Oh my god, I'm stupid. Why am I not remembering this shit? Because if it moves side to side, so you're using in terms of x and y. And if you want to find the hypotenuse angle or the angle between the x and y, you'd have to use sine angle. But if you want to find it's like saying that because it's like saying so I got it, I got it, I got it, I got it. So let's say for example you have a missile and it's going to go front. It's going to keep going front, keep going front, keep going front. It's not going to go straight. It's not going to go. It's not going to go like perfectly straight. It can wobble a little bit, right? You have a sensor, and then you have an X here, you have a Y here. So you're presuming it's like a flat graph. It's like a flat graph, right? When it moves left or right. Now you should understand one thing. It's not like I got it, I got it, I fucking got it, I fucking got it. How do I explain? So if you have like a missile, right? I'm just gonna consider. I might forget about my drawing. So it's gonna move. It can move like that or like that. So it can move left or right. So your graph is not actually like x y, but it's kind of like x, and you have an entire y. It's like instead of like if I were to draw the graph, so that y stretches out, right? So it's like this. You move your arm, and then it's gonna be few, few, and the angle between this is the sine phi, or you can call it sine theta. That's completely fine. We're gonna use um, the azimuthal angle for sine, and we're gonna use a phase angle for cosine. Now this x and z correlate to how much it goes up or goes down, right? So how much it goes up or how much it goes down. That's the phase angle. Yes, that's the phase angle. And so to find if I were to, am I saying it right? So let's say for example, how would x and z look like in a 2D graph? Because 2D graph is x and y, but x and z can also be used. But because that's going up or going down, you're going to use a cosine angle. But x and y is like moving shoop, shoop. So you're going to use a sine angle. So the side slip angle, which is um, the side slip, that's what you call it, it's a side slip angle, right? So because it's going sideways, and so obviously you're going to use a side angle. The angle of attack, which is the pitch up or pitch down, that's the angle of attack, and you're going to use a cosine angle for that. All right, I got it. So I want to explain. I want to explain easy, easy. Side slip angle uses sine. It goes left, right. It goes left and right. The angle of attack, the angle of attack is pitch up or pitch down. Use cosine for that. Correct me if I'm wrong. If I am wrong, I'm here to learn. Here to learn. Okay, I am right. So that's the angle of attack, right? So that's the pitch up or pitch down. That is why, like, Although both are important, but on the previous chapter we saw that the angle of attack will create more of a disturbance as compared to the side slip angle. Side slip angle is good. Like it doesn't mean you shouldn't focus on side slip angle. You should. Like if you were to have an AI sensor, you have to make sure that you focus on the side slip angle. That's very important. But that can be fixed unless and until the coefficient for the side slip angle is is less than zero. It's like very 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 less than zero. Then only then you can fix it. But angle of attack is where majority of the dangers happen, because if it were to go up, it's very hard to fix it. And you must understand, it's a hypersonic missile. So if it were to go up, like it's like seeing a little touch, it can go all the way up. And if it goes up, then it's going to, because if it goes towards the side, yes, your direction or the hit point has changed, so it's going to go somewhere else, maybe, but it's not going to get damaged, right? But if you were to go, angle of attack goes up, it's more frequently goes up so quickly that pretty much your mission is done. Pretty much your mission is aborted. So side slip angle, the forward component V cosine, the forward component and the side component. So forward component is the nose up, nose down. So that is cosine. Side component is a sine. I mean, so sorry, the pitch down, pitch up is a cosine, and the side is the sine, right? Moving on. So finding the trim thrust vector correction. So given that the thrust is 50,000 newtons, the derivative for the thrust vector correction. Where's my um so the derivative for the thrust vector correction is 0.5 meters, not the derivative, sorry, distance. The aerodynamic pitch force, the pitch moment for the aerodynamic force is minus 2000 newtons. So 2000 newtons pitch down, and the gravity is zero, so it's a center. The moment equilibrium, the moment for the thrust vector correction is the, why is the moment of moment equilibrium, the moment for the thrust vector correction is equivalent to the moment for the aerodynamic force, which is plus 2000. And the derivation for the TV, so that's in easy terms, you say the steering, right? The steering change, because steering change for a missile is like you use control the fins. You control using the fins. So if it's like if you keep if you're flying, if the fins are like slanted, then it's going to create more resistance. Which force no? How does the fins of a missile look like? Missile fins. I want to see a live video of it. Missile fins movement. Is that? Let's see.
For the fins to work properly, the missile has to travel at a predetermined height and dive down at incredible speeds. In short, this is how the fins works. They can move left or right, just as shown in the visuals. These control surfaces are dictated by the inertial navigation system or military-grade GPS to turn the missiles to its designated target. When it reaches its target, the impact sensor activates and triggers the warhead and produces a blast equivalent to 500 pounds of TNT, capable of damaging or destroying any bunker in the battlefield.
So these fins can only go sideways, not up, right? It can only move sideways. So if it moves to the right, it's going to move to the right. If it moves to the left, it's going to move to the left. But can the missile fins control the missile to move up and down? Does the missile fins control the missile to move up and down? Yes, as well as side to side. How are they angled? How are the missile fins angled for the missile to launch up. God, I need to learn about. So I need. Oof. I don't know. I'm scared if I'm doing the wrong course because I'm pretty worried. Not gonna lie. I have a question. I don't know if I'm okay. Just wait. Whatever you are explaining. Does this correlate rocket or a missile? Yeah, aircraft has wings. All right. Okay, so the explanation you just explained. You just explained. Can you convert it into? Is it necessary to convert it into lattice square? I mean, you explained everything, right? So trim means all forces and moments sum to zero. Um, so we can find the TVC, like they're finding the thrust vector correction. And so if you want to find the moment equilibrium, then the moment for the thrust vector correction, because my moment for the aerodynamic force is minus 2000, and because I know for a fact that it must be equilibrium, so obviously it's going to be 2000. And solve for the steering for the TVC. So the thrust multiplied by the derivation for the TVC multiplied by the steering of TVC is 2000, which is equal to um, the moment for the thrust vector correction. So 50,000 multiplied 0.5 multiplied by the steering of TVC is equal to 2000. 25,000 multiplied by the steering of TVC is 2000. And so you're going to divide 2000 divided by 25,000. One question. One question. Um, what did you do here? Question. What's the generally I know what's the general equation for the derivation for thrust vector correction? What is the general equation um for finding the steering derivation for the thrust vector correction? The thrust vector correction. From the moment of equilibrium, so the pitch moment is okay. General equation. I need to know this general equation. Is it is it possible to is it possible like the equation you just wrote? Can you convert it into latex code? What you just explained. Yeah, what you just explained. What you just explained. What you just explained. I need this. I need this. I need this. What you just explained. Can you convert it into latex code, please? And the side slip angle and the angle of attack explanation. Can you convert that to latex code? I'm just going to copy this part. But yeah, DeepSeek explains really well. Going to see for it one more time. Just one more time. Just one more time I want to see. So side slip angle, yes. So it uses sine beta, and angle of attack uses the pitched up, pitched down, uses the cosine of alpha. So the side slip angle, there's a left right motion. So V forward will be V cosine theta, V sideways, V forward. V, oh yeah, yeah, yeah. V forward and then sideways, there'll be sine. And V forward, vertical would be cosine. So V forward will be V, okay, V forward will be V cosine beta, V sideways will be V sine beta. And the angle of, oh, V forward. V forward will be V cosine beta, and V sideways will be V sine beta. And for small beta value, sine of beta will be beta, and cosine of beta will be 1. I don't think it's going to be beta, right? It's going to be 0. Okay, sine of beta is beta, like for small b. It's fine. It's fine. And the angle of attack alpha, which is pitch up, pitch down, then V forward will be V cosine of alpha, and V vertical will be V sine of alpha. So why cosine for alpha? When the missile pitches up by alpha, the lift vector tilts backwards. When the missile pitches up by alpha, the lift vector. So the lift vertical will be L cosine of alpha, which is the lift cosine of alpha, and the L horizontal, which is the drag force, that's the L sine of alpha. Can we just wait? Can we do one example for this? One proper example. Can we do one proper example? Is it possible if we can do one proper example for this explanation? And let's do a Python program. So I'm just going to open a Google Colab. Google Colab. Oh, I have Visual Studio Code. Why am I using a Colab? The fuck? Yes, yes, save it. Save it. Import numpy as np. Import matplot. libpyplot splt. Okay, so it worked. Oh, come on. Pip install matplot. Are we good? Yes, we good. I'm gonna copy this here. So after part 2, I'm so sorry that I'm using latex code a lot. I'm so sorry. So given data v is 2500 meter per second, so I'm just going to write them down. This will be Python. So they said that v is 2500, so my given data v is equal to 2500 meter per second. So that's a hypersonic, right? And my beta, that's the side slip angle. Okay, so they said beta angle is 5 degrees and alpha angle is 5 degrees. So that's the side slip angle and that's the angle of attack. And the lift force, like the lift vector going up, like lift in a rocket is going up. Lift in a, it's working, right? Lift in a rocket is going up, only going up. Lift in a rocket is going up, not in a sense that it's going only up, but it's pitching up. The lift will be 50,000 newtons. So that's the total normal force. Total normal force. So I can just probably set them down. So V is equal to, actually not V, set velocity 2500. Side slip angle is 5. Not yet. Angle of attack is 5. Lift force is 50, 1 to 3. So velocity, so that, should it be the velocity vector? Yes. And then lift, why would you need a lift vector? Velocity forward and velocity sideways. So this is the velocity vector in correlation to what? Actually, let me print out. Let me print. Just wait. Velocity vector. Let me just run this and see what I get. I know I'm supposed to get like two values. Yes. So it's kind of like coordinates. And now let's say velocity angle of attack. Angle of attack. Arctan, not arctan. What? Array angle of attack and angle of attack. Sorry. Then we're gonna print the angle of attack. Hmm. The only reason, actually, let's set this as 7.31452678. We're gonna say 6.17165498.9. Cool. Now I got the velocity vector that's going up, no, that's going sideways, and I also got the angle of attack that's going up or down. And the lift vector, the lift force. Missing. I'm going to print the lift vector. So this is, so I'm just going to write print f string, my velocity vector, and I can do the same for this guy, and I can do the same for this guy. So that's the velocity vector. This the velocity vector, yes, the velocity vector in correlation with the angle of attack, and this is a lift vector. How do you get the? Oh, we need to also do a lift vector. This is the horizontal. So this will actually be lift. One thing, one good thing is it's already. So we're gonna do lift vector vertical. The lift vector vertical. Now, how would I? Now, obviously, when you um, obviously you're going to have set values. These are like the values that are already set, right? These are the values that are already set. So you got your velocity, you got your size. Actually, yeah. Am I missing anything? You got the lift force, you got the angle of attack. Like, how would you simulate it in real life? Now, there will be uncertainties. I'm pretty sure there will be uncertainties. How would I actually? I know that there will be uncertainties. I know for a fact that the code that I just did, that's like set value. What in okay the math that we did just now, the maths that we did just now, that is fine and good. But in real life, like during the actual operation, what how like not how, what would what additional What additional configurations do I have to look out for so that it can so that the example can closely correlate to the actual abstract, because you will have uncertainties, because you will have like the air density uncertainty, you're gonna have aerodynamic uncertainty, even this because you will have minuscule uncertainty, and any small disturbances in a hypersonic missile will be big problem, because you never know what will cause. And that's the dynamic pressure, right? The small disturbance will be amplified, because if I were to have very small disturbance, my velocity will increase. So it's like if you have if you have the difference in velocity, let's say 3, then obviously it's going to go 9. But you you're not only focusing on velocity, you're only also focusing on the density, you're also focusing on the pressure. Now this is a hypersonic missile. It's a hypersonic missile, so the velocity is high extensively high. So if I go from 2500 to 2503, if I were to square 2503, the value will be so high. So you see that there's only a small change. 3 meter per second is a lot. 3 meter per second for a hypersonic missile is a lot of change. What do you think? What do you think you have? So yeah, it's that. So you typically have the aerodynamic model. I'll just be back 2 seconds. So, wait, so what do you think you have? You have the derivation for the thrust vector correction. The derivation for the thrust vector correction, the calculated one, is a negative for pitch moment aerodynamic model. So these are all from model. You are going to have uncertainty, and you are going to have the difference for the center of gravity, because the center of gravity will not be exactly a center of gravity. It will be somewhere different. It will be like, even if, let's say, for example, if I were to have a missile, I'm just going to, so let's say, for example, this is your missile, right? So you're going to consider that's a model. So center of gravity is there. But in reality, center of gravity could be here, center of gravity could be here, center of gravity could be here. It can be anywhere. And because of the um, position of where the center of gravity is, the way the missile will operate is also different. So the actual one will be the negative for the aerodynamic pitch moment, the true value, plus the uncertainty, and then for the gravity 2, that will be for the plus the uncertainty for the pitch moment, not pitch moment, center of gravity, divided by the thrust multiplied by the drag force. Actually, can we do an example in correlation to the real life uncertainty? Can we do another example? Another example, this time in consideration with the uncertainties, and convert this convert it convert it into latex code. Let's read it first. So you have an hypersonic missile flying at Mach 7. So the way you calculate Mach is velocity divided by the speed of light. The Mach 1 would be c divided by c. And how do you calculate Mach? How to calculate Mach speed? Local speed of sound. So v divided by a. The velocity of the object, local speed of sound. Right? So a hypersonic missile is flying at Mach 7. Now, and general velocity for a hypersonic missile is 5 Machs. Greater than 5 Mach. Not just 5 Mach, greater than 5 Mach. 5 Mach is small. So we have here 7 Mach. A small wind gust creates a side slip disturbance, but you don't know the exact air density, exact velocity, exact aerodynamic coefficient. So the nominal calculation, what do you think happens is the nominal for the aerodynamic density is 0.01, the nominal velocity would be 2500, nominal side slip is 2, the nominal coefficient for the rotating moment in correlation to the side slip angle is minus 0.04. The reference area is 0.5 meters square, and the b, which is the distance, is 0.8 meters. All stuff. So the nominal dynamic pressure would be half times rho times v square. You do all the pressure and stuff, and then you get the rolling moment coefficient. You calculate the rolling moment coefficient, and the rolling moment L is the coefficient for the rolling moment multiplied by the dynamic pressure multiplied by the reference area multiplied by the distance from the distance from the center of gravity point, right? So let's say, for example, if I were to have a missile, if this is my center of gravity, so let's say it's here. So that B is this one. So that is 0.8 meters, right? So you calculate all that. So it'll roll 1000 Newton per meter. Now this is like, rainbows and sunshines. Rainbows and sunshines. The reality, you're going to have so many uncertainties with the plus 8%, plus 2%, plus 0.5. No, you don't write plus minus. Uh, because in real, like, unlike if you do the lab experience, you can see plus minus. That's uncertainty. In real life, you don't see plus minus. You either see plus or you will see plus minus, but it's like, a range. There is no range. Like in during the operation, there will be no range. If it's a plus, it's a plus. If it's a minus, it's a minus. So it's not going to be like plus minus. So it's like going side ways, right? It's not like a range of value. The true dynamic pressure, you do the true dynamic pressure, you get the the true value and the true rolling moments. You get the coefficient for the rolling moment in correlation to the beta angle multiplied by the beta angle, the true value, you get minus 0.11. So these are the true values. So if you have 0.01 plus 8%, so it will be 0.0108. So you plot all the true values. So this, you do all the calculations and stuff like that. The error blow up. You see how much does it blow up, right? The error will be large for such small values because the core reason why the error will be large is because of your velocity. Everything else remains constant, but your velocity is v squared, not just v. And even a minuscule change in the missile dynamics will create extensively high velocity. And if they do create extensively high velocity, so it's like saying that if I were to change the velocity by 2 meter per second, then my error will be, so where's the velocity? So it went 2500. Now if I do plus 2%, only 2%, please understand, only 2%. So that's 2 by 100 multiplied by 2550. So 2550. My uncertainty is only 2%, and my value, the true value for the velocity is increased a lot. Because you must understand that a small uncertainty change for a velocity, meaning the velocity will add up. And if the velocity adds up, the error will also add up because it's not just v, it's actually v squared. And if I square the real true value, obviously 2500 square 2500 times 2500 is what? 2500 multiplied 2500. Oh, so that is 6,250,000. Now if I do 2550 multiplied 2550, so that is 6,502,500. You see that, right? So it's almost 6502500 6250000. So three, oh shit. So 005252. So 252,500 meter per second difference. You understand? It only jumped by 50 meter per second. Only 50 meter per second. Look at it. Look at it. Oh shit. Look at it. From 2500 to 2550. So that's only 50 meter per second. But after doing all the calculations and stuff like that, I got how much? The difference between the true value and the nominal value, if I squared them, the difference between them was how much? 252,500 meter per second. This is the squared value. I'm telling you, this is the squared value difference. 252,500, even though I only went from 2,500 to 2,550. Because I'm going to use this value, I'm not going to use the 50 value difference. I'm going to consider that the change in value in correlation to v square. Because if I were to consider the change in velocity in correlation to the v square, only then I will be able to find the difference in dynamic pressure, half rho v square. I have half rho v square, not half rho v. If I have half rho v, then my pitch rate will not make as much of a difference, but I have half rho v squared. And because I have half rho v squared, then which means I would have to get the difference in correlation to the v square. And my difference was how much? 252,500. I went only from 2500 to 2550. Convert this into latex code, please. To latex code for me, please. The Yeah, this will be example 2. and label it as example 2. Label it as example 2. Now think about the actual missiles that have a high change in velocity. Think about those ones, right? A small, very small uncertainty. You must understand this 8% is nothing. But for an 8% or for a 2% change, because look, for a 2% velocity change, it only went from 2500 to 2550. But my velocity changed by how much? 250, 2500. So there is a lot. So even a minuscule, so imagine I only changed by 0.1%, right? I'm going to consider this as example 2. And why am I ending a document? That's not end document. What? Not ending a document. Because when you end the document, then it gets the rest of them gets commented. So given what's this? No, did I ruin it? Surely not. Yeah, did I ruin it by any chance? No, right? Or did I copy example 1 2 times? No, I didn't. I didn't. I didn't. It's here. So hypersonic missile flying at Mach 7 and stuff like that. Let's do the Python program for this. Why not? How do you code this in Python? How to program that in Python? Wait. I don't mean like I mean in correlation to the general equations. Not general equations, sorry, the uncertainty equations. That I know. So what I will do is let me just go back here. I have the values, right? I'm just going to set the values. So I have a nominal value. So nominal first real value. So the nominal value is 0.01. You know what? I need to move fast because I have quite a lot of chapters to finish. Quite a lot of chapters. Let's do uh what's this? Part two? No, wait. Can we do section two now? Wait, was the explanation we just did so far? The explanation we just did so far, that's section one? I'm just curious, like the explanation we just did, that's section one? Let me see. No, that I know. At hypersonic speed, large values mean the aerodynamic moment will be large. TVs will be powerful enough to overcome them, and as the pitch moment decreases, the center of gravity will also change. So the center of gravity will actually kind of shift to the left. Just going to copy all. here. Uh, okay, he has it again. I don't know why you're commenting that. The core explanation. So the thrust vector control um, deflection, deflection, which is in easy terms we call it steering, must produce a moment that opposes the sum of aerodynamic and gravity moments. So the moment equilibrium, I think he explained it in the first. Oh shit! The summation for the pitch moment is zero, so which means the aerodynamic moment plus the thrust vector correlation moment plus the gravity pitch moment will be zero. For small angle approximation, the thrust vector correction for the the moment for the thrust vector correction will be t divided times the drag force for the TVC multiplied by sine of del TVC, where because sine of del TVC is approximately equivalent to del TVC, and we did that. The general equation for the sine of beta is approximately beta for small angles. This for small angles. So because it's a small angle, sine of very small value is almost the same value. Where thrust distance from the center of gravity to the engine nozzle, and the nozzle deflection angle. Nozzle deflection angle you call the steering. Substituting into the equilibrium, you get the equilibrium, and then you solve for. Actually, I need to do this. Moment equilibrium is what? So moment equilibrium equilibrium. Just give me 2 seconds. Give me 2 seconds. Just give me 2 seconds. Just 2 seconds. Right. Let us continue. Sorry, my bad. Anyway, so let's move to part 2 now. So substitute into equilibrium. Let's do one example. No, that's fine. That's fine and good. Pitch moment and yaw moment. So the general equation would be del TVC trim T is equivalent to minus m of aerodynamic in correlation to the time, m gravity in correlation to the time divided by the thrust of T multiplied by the distance of the TVC from the center of gravity. An adaptive system estimates the aerodynamic pitch moment from the accelerometers and estimates the pitch moment coefficient, estimates the thrust from throttle setting and engine model, computes the derivation for the TVC trim online. and then add the feedback correction del TVC from. Okay, I didn't understand. I need to understand what's going on. Um, I understood this. Let's do one real life example. Let's do one real life example, like one example that like closely correlates in real life missile operation. Let's do one example that closely correlates to the real life, missile operation with the answer, with everything in consideration, like wind uncertainty, aerodynamic uncertainty, pressure uncertainty, whatever, uncertainty, pressure uncertainty, whatever. I know that even like if I were to read it, I see that there will also be a change in thrust. There will also be the change in distance from the center of gravity to the engine nozzle, the nozzle deflection, everything. So I also see that also based on the notes, I also see that the TG will change, meaning the trim will change, trim changes as a result. You're gonna have what else? The pitch moment will also increase. Pitch moment also changes. The aerodynamic moment changes. Aerodynamic moment changes. Whatever. Then I'm gonna do a Python program for it. That's a lot. That's a lot. Going to this as this. That's until okay. So that's until 4.6. Where is 4.6? The hypersonic missile is ascending through the atmosphere. During a 10-second window, altitude changes, which means the aerodynamic density will decrease, the fuel will burn, meaning the mass of that fuel will decrease, and there's a center of gravity shift, meaning the wind gust appears. Center of gravity shift. The wind gust appears, meaning the side slip angle will change. Aerodynamic coefficients are uncertain. The adaptive guidance system must compute the thrust vector correlation deflection in real time. So the nominal values at time t equals 0. So the initial velocity, initial mass, the fuel mass is 500 kilograms. The initial, what do you call nominal, aerodynamic density is 0.01. The velocity is 2500. S 0. So S is the reference area, tail area, but the reference area, whoa. So S being the tail area, the B being the distance from the center of gravity to the engine nozzle, that is 0.8. What is C? What is C? What's that? Or did they explain it? I don't think they explained it. Nope. I don't think they explained it. I don't know what that is. A chord. Chord is 0.6 meters. The initial thrust is 50,000 newtons. The distance from the center of gravity to the engine nozzle is 0. Distance from the thrust vector correction. Okay, what was okay? Wait, what is D of TVC? Distance from CG to engine nozzle. What is B then? If D of TVC is that, what is B? What is, what are each of those? What do each of those represent? What do each of those represent? So initial mass, air density, velocity, reference area, reference span. So side view. You have a length. You have a chord that's a wing. You have the tail. You have, okay, so it's that way. You have a chord. Okay, what? You have a length. You have a chord. Okay, let's see. Chord in a missile. Chord missile. No. How does a chord look like in a missile? Solid fuel rocket booster, jet engine, fuel tank, warhead, intercom system, internal guidance system. There should be a label or something like that, right? Is that in German? Nope. Yeah, this green stuff. Me open image in new tab. You have a warhead, igniter, warhead. You have a center tube. You have the equipment room. There's the missile control. You have a fuel tank. You have a suction line. Oxidator tank. What's an oxidator tank? Wasserstoff. Wasser. What? Wasserstoff peroxide. Pe- fuck. Wasserstoff peroxide tank. Peroxide tank, not peroxide, peroxide tank. Wasserstoff peroxide tank, thrust stand, turbo pump, stabilizing fin, fuel line, engine, thruster, spoilers, antenna, and start table. So that's the entire missile? Is that's the entire one? No, this here. So which one's the chord? Okay, so from here, like from based on this image, which one's the chord? Based on this image, which one is the chord then? I'm still learning. I'm still learning. The Valentina posted. Probably Valentina posted. She posted. No, she didn't. Oh, she followed. Is that his wife now? Or husband, I think. Nice. Or you might think, ha, got it. Let me wait to read. Haha. Unfollow. Fuck you. Anyways, missile body diameter and this. Okay, I don't understand jack shit. What the fuck are you saying? So we have, okay, so that's the initial mass, that's the fuel mass, that's the aerodynamic density, that's the velocity for the missile, that's the reference area, that's the reference length, that's the chord, that's the initial thrust force, that's the distance from the center of gravity to the engine nozzle, that's the center of gravity at 40% chord, and this is the neutral point, which is 0.5. Static margin at t equals 0, so the static margin would be the neutral point minus the center of gravity at 40% core, which means 10% core. What did we do there? You have a lot of complex values. So I'm not understanding, like, what the fuck is this? What the fuck is this? I don't understand jack shit. So you have a lot of complex values. Can you explain slowly? What's this? Like, calm down, my guy. Calm down. Calm down. So I want to understand this thoroughly again. Uh, yeah, I want to understand this one more time. Like, what is going on here? Can I know what is going on here? No, I know, but explain it easy. Okay, stop. Stop. There are 9 parts. Explain part one only. Explain part one only, slowly, step by step. So this part at the very beginning of the flat, what does the thrust vector correlation deflection do? What thrust vector correlation deflection do we need? So what does nominal mean? Nominal means the ideal, perfect, no errors, no uncertainties, everything exactly as designed. So T is equal to 0, missile is on the launch pad or just released. No fuel has burned yet, no wind gust yet. All sensors read exactly what they should. And the given numbers, so you have the initial thrust mass, which is 500 kilograms, total missile weight at launch, the rho naught, which is the 0.01 kilogram per meter cube, the air density at launch altitude, very thin air, the velocity, the initial velocity, there's 2500, so mark around 7.35. The the reference area is 0.5 meter per second squared. This like the span length is 0.8 meters. The mean aerodynamic port, that's the average length for lifting the surface, 0.6. Initial thrust force is 50,000. Distance from the center of gravity to the engine nozzle pivot is 0.5. The what's that? The chord location, not chord location. Center of gravity location is 40% of chord back from nose. 40% of chord back from nose. What does that mean? You don't make sense. What is this? What is this 40% of chord? What does that mean? 40% of chord back from nose. What does that mean? What does this mean? 40% of chord back from nose. Wait, that account exists? No, no. Why does this account exist? Shut up. This account shouldn't exist, right? What? This account exists? Oh yeah, Valentina Gomez. No. What the fuck? Nah. Wait. I don't give a shit. Nah, wait. Wait. Now you're joking, right? What? pictures. Dude, give me fucking green screen for fuck's sake, man. Holy fucking cornball. Okay, there. Oh, okay. I don't mean media. I meant image. Okay, please just wait. Shut up. Shut up.